Welcome to GER Hub Mathematics and Statistics Lessons. Today I'm going to be talking about a very interesting topic in mathematics called matrices, and I want you to pay careful attention. So I'm going to be doing three things in this video. I'm going to be talking about the definition of what is called a matrix. I'm also going to be talking about the order of a matrix, and lastly I'm going to talk about how to locate elements in a matrix. Okay, so three things will be done in this video: the definition of a matrix, followed by the order of a matrix, and then the specification on location of elements in a matrix. So let us begin. So our topic is matrices. Now take note, matrices is plural for the word matrix. So let's start with itemizing what we shall do in this video. So the first thing is to answer the question, what is a matrix? What is a matrix? We shall answer this question in this video. The next thing we shall talk about is, what is the order of a matrix? What is the order of a matrix? So what do we mean by the order of a matrix? Then the third and final thing we shall talk about in this video is how can one locate elements in a matrix. So those are the three things we shall be talking about in this video. So let us start quickly with objective number one. What is a matrix? Okay? So I'm starting with objective number one. What is a matrix? Good. Now, a matrix is an array of elements. A matrix is an array of elements, usually numbers, in rows and in columns, enclosed in a bracket. So I'm going to take my time to explain this definition so that you end up understanding what a matrix is at the end of this video. So what is a matrix? A matrix is an array of elements, usually numbers, in rows and in columns, enclosed in a bracket. So come over to this point and let's see what that means. By that definition, it means what is called a matrix looks like this. I could have 3, 2, 1, 4, 5, and 6 put in this structure within a bracket, and that will make a matrix by the definition, because there is an arrangement here having elements 3, 2, 1 in rows, 4, 5, 6 in rows, and then 3, 4 in columns, 2, 5, 1, 6 in columns. Now I'm going to start to clarify what we mean by rows and what we also mean by columns. So in our idea of matrices, we use the horizontals to represent rows. So the horizontals are rows, but the verticals, these verticals are columns. Okay? So we start with the first row. The first row begins from the top and goes to the bottom. So the first row is this. This we shall call row 1. And the second row is this, which we shall call row 2. Now, for the columns, we start with listing columns from the left straight to the right. So this will be called column 1. I'm going to use C1 to represent column 1. This we shall call column 2, and the third we shall call column 3. So in matrices, we have rows and we have columns. Rows begin from top to bottom, the horizontals from top to bottom, while columns progress from left to right. So if this is the first row, it will be defined as row 1. This will be called row 2. And in this matrix, this will be called column 1 because it is the one we begin with to the left this we shall call column 2, and this we shall call column 3. Okay? Now, the next thing I want to say is that using another example, I want to show you that matrices must not and should not only contain numbers. Sometimes a matrix could contain elements other than numbers. So I could have E, I, O, U, and that will still be a matrix. So our definition of matrices must not be restricted to numbers alone. It could also involve letters or other items other than numbers, okay? So this could be a matrix because it obeys the structure of our definition and is also enclosed in a bracket. So using the same convention of our description on rows and columns, you will notice that we have two rows here, with the first one being this, row 1, and the second being this, row 2. Clearly, row 1 in this case contains two elements, E and I, and row 2 contains two elements, O and U. Similarly, we also may have this to be, or we have this to be column 1. I'm going to write here C1 representing column 1, and the second being this called column 2. So in this second matrix, we have two rows and two columns. So I want you to remember that matrices contain rows and columns. By the definition, it is an array of elements, usually numbers, contained in rows and columns enclosed in a bracket. So that explains the definition of a matrix. Now before moving on, let's look at several examples of matrices. So you could have this to be a matrix, 0, 4, 2. This could mean or refer to a matrix. You could have a matrix like this containing orange, apple, guava, and then pineapple. This could also refer to a matrix. Okay? So matrices must not be restricted to numbers. They could also in structure be representing entities other than numbers. Okay? So let's quickly move to the next objective of this topic. And what is the next objective? We want to answer the question, what is the order of a matrix? What is the order of a matrix? So quickly, I'm going to clean this off. What is the order of a matrix? So let's see what the order of a matrix is quickly. Now, I'm going to write here order of a matrix. So, what is the order of a matrix? The order of a matrix is a specification of the number of rows by columns contained in the matrix. Again, the order of a matrix is a specification of the number of rows by columns contained in the matrix. Now, aside that definition on the order of a matrix, there is something else I want you to know, and it is very, very important, so please pay attention. I want you to know that even as we've defined the order of a matrix to be a specification of the number of rows by columns contained in a matrix, I want you to know that there is a convention. There is an agreed way of specifying the order of a matrix. Okay? So the question is, what is this conventional way for specifying the order of a matrix? In this topic, matrices, order of a matrix is specified starting with mentioning the number of rows and using a multiplication sign to represent by, followed by the number of columns. So if a matrix has, for instance, if a matrix has m rows, if a matrix has m number of rows and n columns, then the order of the matrix will be, the order of the matrix will be m by n, and this is read as m by n, okay? So we use the multiplication sign to represent this word by. So the convention, the agreed way of doing this specification that tells the order of a matrix is to start with writing out the number of rows followed by the number of columns. So if a matrix has m number of rows in it and n number of columns, that matrix will be called an m by n matrix, okay? If a matrix has m number of rows and n number of columns, the matrix will have an order called m by n. So remember, the order of a matrix is a specification of the number of rows found in that matrix by the number of columns, okay? Now let us look at examples of matrices. So come over here, let's see. Let's put up examples of matrices, or the order of matrices. So I'm going to put up, for example, this. What will be the order of a matrix like this? What will be the order of this matrix? Now, for me to tell the number of, or the order of this matrix, I only have to count the number of rows. And remember, rows represent the horizontals, verticals represent the columns, okay? So if I want to tell the order of this matrix by our definition of the order of a matrix, then I have to count the number of rows. How many rows do we have here? 1, 2, 3. There are 1, 2, 3 rows. So I'm going to start with writing 3 here, representing the number of rows. I'm going to count the number of columns. There are 1, 2, 3 columns. 1, 2, 3 columns. So that means this matrix will be of order 3 by 3. Okay? That 3 by 3 is written as 3 times 3, but it is pronounced as 3 by 3. Now, what if, again, we were given a matrix like this to tell the order? 2, 1, 5. The order of this matrix can also be obtained by telling the number of rows by column. So, looking at this matrix, you would notice it has only one row, which is the row 1. But looking at it again, you will notice it has 1, 2, and 3 columns. So, if you want to specify the order of this matrix, you would have to write 1 being the number of rows by 3 being the number of columns. So, this matrix 2, 5, 1 will be called a 1 by 3 matrix. Okay? Now, I'm going to put up another example of a matrix whose order I would want us to tell. So let's see. What about a matrix like this? What about a matrix like this? I'm going to call this C. So what about a matrix like this? 3, 5, 4, 2, 1, 6, 8, 9, and 4, 5, 0, 2. What about a matrix like this? What will be the order of this matrix? The order of this matrix will be told if we can count the number of rows by column. So how many rows do we have in this matrix? 1, row 1, 2, row 2, 3, row 3. So there are 3 rows in this matrix. I'm going to put here 3 by, how many columns do we have? 1, 2, 3, and 4. Meaning that the order of this matrix will be 3 by 4. So we can call this matrix a 3 by 4 matrix. Remember, why is it called a 3 by 4 matrix? It's simply because in this matrix we have 3 rows and 4 columns. Okay, so this is a 3 by 4 matrix. Now lastly, I'm going to put up another example. What is the order of this matrix? 4, 5, 6, 2, 1, minus 1, 6, 3. What is the order of this matrix? Again, let's count. 1, 2, 3, 4. We have 4 rows. So I'm going to write 4 by, how many columns do we have? 1, 2. So this matrix will be called a 4 by 2 matrix. So for you to tell the order of a matrix, all you have to do is simply count the number of rows by the number of columns. And how do you specify that? Put the number of rows and use a multiplication sign to represent by, followed by the number of columns, and that will do for the order of a matrix. And I hope you get that. I'll be expecting your comments down below. Okay, so let's see the third objective. That concludes the second objective in this class. The third objective is how can one locate elements of a matrix or in a matrix. How can one locate elements in a matrix? So I'm going to clean this off to do something immediately. So how do we locate elements in a matrix? So now let's start with, before answering that question, let's start with what is called the general matrix. Now, the general matrix represents something I want to explain. Take note, in my examples of matrices, I have been using numbers, and I've been using letters, I've been using oranges, fruits, and the likes. But what I want to describe here is something about the general matrix. Under the general matrix as a subtopic, I want to say something. Matrices are specified or denoted by uppercase letters. So if you want to specify a matrix, then you should be using uppercase letters. So letters like uppercase A, uppercase B, uppercase C, and the likes will represent a matrix, while lowercase letters are used to represent elements in a matrix. So whereas we use uppercase letters to represent matrices, we use corresponding lowercase letters to represent the elements of a matrix. So let's see, if I have a matrix A, if this is a matrix A, let's say I have a 2 by 2 matrix A. Now, it is expected that the elements will be corresponding letters A, and A. Now, notice one thing. The matrix, by what I've just written here, is denoted by uppercase A, but the elements are denoted by corresponding lowercase a. But what we want to do in this segment of our video, it is to tell you how to locate elements in a matrix. Now take note, we can't just leave these letters A or A and A in this matrix. We have to tell their location. If you were asked, what differentiates this A from this A? All of them are A's, but they do not occupy the same position in the matrix. This one occupies this position, being the topmost left. This one occupies this position, being the bottommost right. So how do we tell the difference in their location is what I want to explain in this segment of the video to round it up. So if a matrix is A and it is of order 2 by 2, we could use corresponding lowercase a's to represent the elements in the matrix. But for us to tell the exact location of each of these a's in the matrix, we have to use what is called the subscript notation. Okay? Now, the subscript notation starts with telling us the row in which an element is found, followed by the column in which that same element is found. So what I'm going to do is this. Please, if you look at this A, being the first A, the topmost left element, you will notice that it's an A that occupies the first row. It is found along the first row, and for the columns, it is found along the first column. So I'm going to use 1 to represent the fact that it is found along the first row, and to represent the fact that it is found along the first column, I'm going to use another 1. So A11 is what we now have for that element, meaning that that element is found along the first row and along the first column. Moving to this other element, you will notice that this element is found along the first row but along the second column. So to show that it starts or is found along the first row, I'm going to put 1 here. And to show that it is found in the second column, I'm going to use 2. So A12 represents the element in the matrix A that is found along the first row but second column. And by similar convention, you will end up having this element A here occupying the position 2, 1. The 2 there stands for the fact that it is found along the second row but the first column. While this particular element here will be having a subscript 2, 2, telling us that it is found along the second row but the second column, or the second column. Okay? So this is what we mean by locating elements in a matrix. Now, I'm going to show you where that is applied, but let us try doing that for so many other matrices I'm going to put on this part of the board. Okay? So let's see. Let's see how that goes. So if I have a matrix B, to show you how we apply that concept, if I have a matrix B carrying 4, 3, 2, 1, 6, 8, and I want you to use the idea of the general matrix to represent this. This is synonymous to writing B, 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 and B. Now take note, this matrix, by what we discussed on the order of a matrix, is clearly a 3 by 2 matrix, simply because it has 3 rows, 1, 2, and 3, but 2 columns, 1, 2. Okay, so this is a 3 by 2 matrix. Now, if we want to use the location, the idea of locating elements, if we want to use the idea of locating elements to describe this, matrix, let's see how that is done. So, like I told you, if a matrix is represented with uppercase B, then the corresponding elements will be represented as lowercase b's. But for us to tell exactly what the location of each of these elements are, we are going to use this. So let's see. Now, this B here, all of them are B's because you have the uppercase B representing a matrix, but this particular B would carry the location number 1, 1, meaning that it is found in the first row and first column. This other B would carry the location number 1, 2, telling you that this particular B is found in the first row but second column. This particular B here is found in the second row, first column. So that would be B21. This particular B will be found in the second row, second column. So it makes it B22. Then this one here, the third one is found in the third row. So I'm going to write 3 and the first column 1. While the last one here is found in the third row, second column. So if you were to ask, if you were to be asked to locate the element 4 as found in this matrix, the element 4 occupies the position B11. So we simply write B11 equals 4. If you were asked to locate randomly the element B32, it will be B32 equals 6, or 8 rather. B32 equals 8. If you were asked to locate the element B21, we simply write B21 equals 1. And if you were asked to locate randomly the element B12, we would write B12 equals 3. So, locating elements in a matrix is simple. All you have to do is to understand the general matrix. So, the general matrix is a description of a matrix in the sense that a matrix is represented by an uppercase letter while its corresponding element is represented by a lowercase letter. Okay, to show you precisely something about the general matrix, take note, in the general matrix, it is assumed we do not know the number of rows and the number of columns. So, what if you were asked to represent the general matrix carrying m rows and n columns? I'm going to end my class with this, but let's see. So there is a matrix A of order m by n, and we are asked to describe this matrix. Let's see how that is done to bring our class to a close. So I'm going to do this simply. I'm going to start with writing A11, standing for the first element occupying the first row and first column. I'm going to write A12 representing the first element the element occupying the first row, second colon, I'm going to write A13 representing the element occupying the first row, third colon. Then I'm going to put ellipses, and then that is just to show that the counting continues, or the elements continue to the nth colon. So this will now be row 1, the element found in row 1, but colon n. Remember, there are n columns in this matrix. So if I move over to the next row, this will be A21 representing the element in row 2, colon 1. This will be A22 representing the element in row 2, colon 2. This will be A23 representing the element in row 2, colon 3. And I'm going to put ellipses showing that it proceeds to the very last element along that row. And the very last element will be found in row 2, but colon n. Now, I can do the same thing for A31, A32, A33, and then up to A3n. But because I do not know the number of rows, n is just an alphabet representing the number of rows. So since we don't know, I'm also going to put ellipses here to show that the number of the elements continue up to the mth element. That is the mth element, okay? So that will now be AM1. This will represent the element occupying the mth row and first column. And I'm going to do the same thing here. This will be for AM2, showing you the element occupying the mth row, second column. This will be for AM3, showing you the element occupying the mth row, third column. And it will proceed to the last element in that row, which will be AMN, showing you that this element occupies the nth row and nth column. I want to believe you will go through this video once more, and with everything we've said, you'll be able to define a matrix. You'll be able to tell the order of a matrix, and you'll be able to locate elements in this matrix. So do like our video, share our video, and most importantly, subscribe to our YouTube channel, as this would help grow the channel. I'll see you in the next class. Thank you.